Hi, math students. It's Miss Carol. I am going over the Algebra 1A checkpoint 1 for you today. My reason for that is that checkpoints have proven to be kind of a sticking point for students. A lot of times the answers are a little tricky and ambiguous, and so I'm hoping to give you some strategies for tackling these checkpoints. So what I'm going to do is just work through a couple problems here and go ahead and show you a couple things that I do. Okay, the first question is, which of the following answer choices can be rewritten to become an exponential expression with a single base? So hopefully, based on lesson 1, you all now know that an exponential expression would be something like x to the 4th power, where x is our base and 4 would be our exponent or our power, okay? So in this instance, they only want a single base, so they only want a single number or letter as the base, okay? So z to the 4th times z to the 4th, okay, can be written as z to the 4 plus 4 power, right? Which equals z to the 8th. Okay, notice I have one single base and I have one exponent. Okay, so that qualifies as an exponential expression with one single base. The reason that I can do z to the 4th plus z to the 4th, or excuse me, z to the 4 plus 4, is that z to the 4th is z times z times z times z, and z to the 4th again is z times z times z times z. Okay, so you'll see that I now have 8 z's. So when I am multiplying two bases that are identical, I can then add their exponents. All right, so that one works. Go ahead and erase and look at the next one. Okay, now I've got m squared over m to the 6th. Well, I do just have one base, so I can probably combine these. And when I am, well, let's look at this the long way first. I've got m times m over m times m times m times m times m times m. Okay, now normally you would just cancel these out, right? And so I'm left with 1 over m to the 4th power, okay? Another way to write this is m to the negative 4th. We can move an exponent between the numerator and the denominator by simply switching the sign of the exponent, okay? So m to the negative 4th is the same as 1 over m to the 4th. All right. The other way to think of this is m to the 2 minus 6th power, which is m to the negative 4th, which, as we've already decided, is 1 over m to the 4th. Okay, when I am dividing two bases that are identical, I can subtract the exponent in the denominator from the exponent in the numerator. Okay? So division and multiplication kind of work the same as addition and subtraction. All right. Now, so this one works because I can combine it into that single base. Let's look at this one. I've got c to the 7th over d to the 7th. Notice that while my exponents are the same, my bases are not the same. So there's no way that I can combine them. Same thing with this last one, v to the 5th over w to the 5th. While the exponents are the same, the bases are not the same, so I don't have the ability via the properties of exponents to combine these. Okay, so the only two answers that make sense here are the first two that we looked at. Okay, so we'll go ahead and scroll down. And let's go ahead and look at number 2 here. rewrite the expression 8 to the 6th. Oh, actually, one thing I want to show everyone really quickly is this, that if you have a hard time seeing this, you can highlight it and it'll pop up for you. Okay. So 8 to the 6th times 8 to the 3rd over 8 to the 5th. Well, notice that all three of the bases are the same, and so we can easily work with this. All right. I'm going to start with what's in the numerator, and I'm going to go ahead and add those exponents. So 8 to the 6th plus 3 over 8 to the 5th. So 6 plus 3 is 9. 8 to the 9th over 8 to the 5th. And now I can subtract the 5 from the 9. 8 to the 9 minus 5 equals 8 to the 4th power. And when you type this in, of course, you type 8, shift 6, 4. And it'll look like a regular 4. Okay? All right. Okay, this is kind of a fun one. We've got a box with sides A and B, and they want us to decide how to represent the volume of this box. And as you should all know, volume of a box is length times width times height. So we will say LWH equals A times B times B. Okay, and they want to know what are all the ways that that can be represented. Well, this is it. So we can say, well, okay, this first one works. That's great. Let's see what our other options are. And let me scroll here for a second. Go ahead and erase that. Okay. And let's see if I can, let me move it. Okay. So we know it's A times B times B. We can combine the two B's and we can say A times B squared. Okay. But that's pretty much all we can do. We can't do A squared B squared because A squared B squared, if you expand it out, looks like this. So that doesn't work. And this is the one that most students mistake here. And they say, oh, it's A times 2B because there's two B's. But there's not actually two B's, there's B squared. So just to be really clear, B times B equals B squared, not 2B, okay? B plus B equals 2B. And that's a very big difference. B squared and 2B are not the same thing. So it's a difference between addition and multiplication. And so, again, you do have to look at every single one of these. This one is going to expand out to the same thing as this one. It would be A times B times B. And we know that there's really only one A. So the only two that work here are these two. Okay, I think that the big hint that I'm giving here is that you really do need to look at all of the possible answers and basically do about 4 math problems per checkpoint question. Okay, that one will be very similar. Okay, here's one with actual numbers that I think will probably be a good stopping point for me. Okay, so they want to, again, determine which answers can be written, or which problems can be written as exponential expressions with a single base, very much like we did at the beginning, but this time we're going to do it with actual numbers. And I want to show you a way that when you're dealing with actual numbers, you can also check your answers. So the first one that we have is 3 squared over 3. So if you'll remember that division property of exponents, when I have the same base, I can subtract the exponent in the denominator from the exponent in the numerator. And this exponent, let's go ahead and expand it, pop it out so you can see it. There's actually a implied 1 right here. Okay, so this becomes 3 to the 2 minus 1, which is 3 to the 1, which is simply 3. So this is a true statement. Okay. All right. I want to show you a really cool trick. If I go to Google and I type in 3 squared over 3, I get 3. And so you can actually check the math on these really easily, and I definitely encourage you to do that, especially when they get even more difficult. Okay, so let's look at the next one. 4 to the 7th times 4 to the 5th. Well, now we're multiplying exponential expressions with the same base. Okay, so that means that we can add those exponents. So 4 to the 7 plus 5 equals 4 to the 12th. All right, well, let's just check it on our calculator really quickly. So we're going to redo this, and we're going to say 4 to the 7th, and we're going to multiply that by 4 to the 5th. Okay, that equals, let's see, we're going to 16,777,216. Okay, let's just check to see that 4 to the 12th actually equals that same value. 4 to the 12th. Oh, look at that. It does. Okay. So isn't that a really cool little use of our calculator? And really, again, use it. Use it, use it, use it. Okay. Let's go ahead and just check these other two, because again, you've got to check them all. 10 to the 3rd minus 2 to the 3rd. Okay. We do not have the same base. We have the same exponent, but we don't have the same base. So we really can't do anything here. And so I want to check this again. I happen to know that 10 to the 3rd is 1,000 and 2 to the 3rd is 8. So that would equal 992. So I'm going to just check on my Google calculator really quick if 8 to the 3rd is 992. I don't think it is. 8 to the 3rd. Nope, it's 512. So good thing I checked, so I can know for sure that that doesn't equal. Okay, now I've got 5 squared times 8 squared equals 40 to the 4th. Okay, again, they tried to add the exponents, but the base wasn't the same. So that's just not going to work. So I know that 5 squared is 25, and I know that 8 squared is 64. I'm going to just check real quick to see if 25 times 64, 25, oops, let's undo this here. 25 times 64, 1600. Let's see if that is the same as 40 to the 4th power. No, it's nowhere near. So I know for sure, again, that that one doesn't work either. But I already should have known that because the bases weren't the same. So multiplying those bases together wouldn't work either. We can't combine them that way. Okay. That's all I'm going to do for now. Thank you very much for taking a few minutes. I hope that helps you with checkpoint 1.